morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, I want to discuss the problem solving on eccentrically loaded riveted joints. So already we have discussed in the previous sessions. So eccentrically loaded riveted joints, how to calculate the eccentrically loaded riveted joint dimension calculations. The procedure also we have seen. But in this session, so we will take one problem and how to solve these type of problems when it is subjected to eccentrical load. So see, here given problem, an eccentrically loaded lap riveted joint so is to be designed for a steel bracket as shown in figure. So in this figure, you can identify the eccentrical load is P and the E given, that is eccentricity. And here total number of rivets are 1, 2, 3, 4, 5, 6, 7. So the number of rivets are here 7. Clear? And the distance between the diagonal, the perpendicular distances between rivets are C, and linear distance is C given. So for this eccentrically loaded lap joint, need to calculate the dimension of a size of the rivet. So the bracket plate is 25 mm thick. So the dimensions are 25 mm thick. All rivets are to be same size. Same size, all are equal. Load on the bracket is 50 kN. Clear? Rivet spacing 100 mm. Vertically and horizontally, the rivet spacing is 100 mm. The load arm, that is E, eccentricity, the load acting distance is 400 mm. So it means the line of action of load, distance from its center of gravity, that is E, 400 mm given. The permissible shear stress is 65 megapascal and crushing stress 120 megapascal. Shearing 65 and crushing 120. So determine the size of the rivets to be used for the joint. So he has asked what is the size of the rivet. So how to solve this the problem, we'll see. So first of all, so write down the given data. The thickness of the plate is 25 mm and load is 50 kilonewton. Convert into newtons. So the distance is 400. Here number of rivets are 7. And tau is equal to 65. Megapascal given, you can convert into Newton per mm square. So that is 65 Newton per mm square. Sigma C is equal to 120 megapascal is converted into Newton per mm square. 1 megapascal is equal to 1 Newton per mm square. So 120 Newton per mm square. So remaining dimensions are shown in this diagram. C 100. As per procedure, first of all, find out the center of gravity. So the first of center of gravity, X bar and Y bar. X bar and Y bar, calculate. And then draw the shear force, primary shear force diagram, primary shear stress diagram and secondary shear force diagram. So, and mark the all the remaining points like L1, L2, L3 and F1, F2, F3, F4 up to 7, so on. And direct shear stress and secondary shear F1, F2, F3 up to F7. These are secondary shear stresses. Need to calculate these two stresses and then find out the angle between these two. Then only you can calculate the resultant of this shear load. The first of all, find out the X bar and Y bar. So the X bar is the distance of center of gravity from YY and Y bar is distance of center of gravity from YX. So that is a horizontal distance and a vertical distance. See, in this X1, X2, X3, distances the center of gravity of each rivet from OY and Y1, Y2, Y3, distances of center of gravity of each rivet OX. Already we have seen in previous session. So x bar, now calculate x bar. The given x1 is, so what is the x1? 100. So distance from first rivet value is 100 from its center of gravity. The second one also 100. Clear? So third one 100. Sorry, third one 200 and second one 200. So like that, calculate x bar. You will get 100 mm x bar. Here x1, x6 and x7 are 0. There is no distance x1, x2 and x3. So y bar. Similarly, y bar calculate. Here y5 and y6 is equal to 0. So here the center of gravity of the rivet system lies at a distance of 100 mm from yy. And y bar distance 114.3 from its from OX. So x bar is equal to 100 mm, y bar is equal to 114.3 mm. So now calculate shear load. So in this eccentrically loaded joints, two types of shear stresses are there. One is primary shear stress and second one is secondary shear stress. So in primary shear stress, you can calculate by using a given load. The secondary shear stress procedure also, we will see how to calculate the secondary shear stress. So in this direct shear load, direct shear stress is equal to direct shear load upon number of rivets. The direct load is here given 50 kilonewtons upon number of rivets 7. So you will get a direct shear load. And as it is parallel to the direction of load P. So that is vertically downwards as shown in the figure. So see, so in this the turning moment produced by the load P. So here due to the eccentricity, that is P into E. So P multiply with E. So you will get the turning moment, the twisting moment. Due to this twisting moment, secondary shear stress will occur. So again draw this diagram. So two forces, two shear stresses are there. One is direct shear stress, another one is secondary shear stress. Similarly, at 2, the direct shear stress and direct secondary shear stress. The third, direct shear stress and secondary shear stress, like that up to 7. Similarly, L1. L1 is the first rivet distance from its center of gravity. L2, second rivet. L3, fourth rivet. And L4 and L4, fourth rivet. L5, fifth rivet, like that. Up to 7. Here, 7 rivets are there. Clear? And then find out the angle between these direct shear load and secondary shear load. So how to calculate the resultant? Equation already you know. This resultant of these two forces R is equal to square root of direct shear stress square plus F square plus 2 PS into F multiplied with cos theta. Clear? So you will get the resultant. See, in this from the geometry of the figure, you find L1, L3 and L2, L4, L7 are equal and L5, L6 are same. Clear? So you will get L1 and L2, L3, L4, L5, L6 distances from its center of gravity. Now equating the turning moment due to eccentricity of the load to the resisting moment of these rivets. Clear? So the turning moment, twisting moment is P into E. Equate to this resisting moment. So the resisting moment values are F1 by L1. Take common and use this equation. L1 square plus L2 square plus L3, L4, L5 square, L6 square, L7 square. So similarly, you will get the F1 by L2, the final equation you will get. Here, because L1, L3 are same and L4, L7 are same and L5, L6 also equal. So you simplify this equation as F1 by L1 multiply with inside bracket 2 L1 square L2 square, L3 square to L5 square. So substitute this moment, the P into E. So the P into E, P value 50 kilonewtons, E, the eccentricity is 400, equate to this resisting moment. Clear? F1 by 131.7, and the remaining values already you know, L1 square, L2, L3 square. So if you so in this unknown is force F1. Clear? So that is a secondary shear force. So find out secondary shear force. You will get 244 newtons. After that, the secondary shear loads are proportional to their radial distance from the center of gravity. So therefore, so again use this relation, F2 is equal to F1 into L2 by L1. So after calculation of F1, if you know the F1, so you can calculate remaining F2, F3 and F4 values. Clear? So F2 is F1 into L2 by L1. Similarly, F3 is equal to F1 into L3 by L1. And F4 is equal to F1 into L4 by L1. So find out these three, and again 5, 6, 7 also. After calculation of all these forces, so by drawing the direct and secondary shear loads on each rivet, so we see that. So here, identify the heavily loaded. So here in this diagram, 3, 4, 5 are heavily loaded. So why? Because find the angles between the direct and secondary shear loads. 3, 4, 5. See here 3, 4 and 5. These the rivets are heavily loaded when compared to the other rivets. You can identify with the help of these angles, theta 3 and theta 4 and theta 5. Clear? 3, 4, 5 heavily loaded. So let us now that find the angles between the direct and the shear loads of these rivets. From the geometry you can calculate cos theta 3 and theta 4 and theta 5. So find the resultant shear load on rivet 3 and rivet 4 and rivet 5. So resultant shear load on rivet 3. So by using this relation, square root of ps square plus f3 square plus 2ps into f3 into cos theta 3. Parallelogram theorem. So as per parallelogram theorem, find out the resultant. So we will get 30,033 newtons. So resultant shear load on rivet 4. To find out resultant shear load on rivet 4. Similarly, resultant shear load on rivet 5. So already you know the theta 3, theta 4 and theta 5 values. Substitute in this equation. So we will get the resultant forces on rivet 3, 4, 5 at which heavily loaded in the joint. These 3 and rivet 3 and rivet 4 and rivet 5 joints are heavily loaded. By seeing the figure, we can say which one is heavily loaded. So the resultant shear load may be determined graphically. The resultant shear load from the given figure. So from you see that the maximum resultant shear load on rivet is rivet 5. So which one is maximum? The rivet 5 is the maximum value. So this is 33,121 newtons get. So the diameter of the rivet wall, then maximum resultant shear load. So the diameter of the rivet wall you can calculate by using this maximum resultant shear load. So which rivet is undergone maximum shear load, resultant shear load. So at that rivet, you need to calculate the dimension of the rivet. So the maximum resultant shear load equate to this the area multiplied with shear. So this is area of the rivet. We don't know D. We need to calculate D value. So equate this the maximum resultant shear load to area multiplied with shear. So clear shear the strength. So then we will get diameter of the rivet. So that's finally you will get diameter of the rivet is 25.5 mm. So like this, you need to calculate the rivet size for eccentrically loaded riveted joints. Clear? Next, so finally, after determining the size of the rivet, need to check for crushing stress. Is it withstand for crushing load or not? So then only you can say this joint is safe. So when design is, you can say this design is safe or design is not safe. Clear? How to check this crushing? Here we will see. So find out the crushing stress, the maximum load upon crushing area. So here the maximum load occur at rivet 5. Clear? So the crushing area is D into T. So already you know the diameter of a rivet and multiply with T. So you will get the crushing load is 51 point, the crushing stress is 51.95 megapascal. So this stress value below the given stress value. So then only you can say their design is safe. So what he has given in the problem C. So he has given 120 megapascal the crushing stress. This is the maximum crushing stress. Always this crushing stress value, calculated crushing stress value should be less than the given ultimate maximum stress value. So then only your design is safe. It may be crushing, it may be shear, it may be any type crushing. For you can check for crushing, you can check for tensile, you can check for shear also. So but remember this calculated value should be less than the given value. Then only the above design is safe. That it means the design is satisfactory. So like this, have to solve this type of problems. Clear? Thank you. So these are the references.
Like, share and subscribe. Hit the bell icon for more updates.